Question number 4 from 13.3. We had, I think, just discussed what the question is, and we have to write down the answer. I hope the question is clear. If anyone wants to ask anything, you can ask right now. This is question number 4. So the well is of diameters 3 meters. The depth of the well is 14 meters. And then there is the embankment with width 4 meters. So let's represent the radii and height. Now for well, I'm using R and H as in lowercase. Let's keep this in lowercase. So radius of the well can be calculated from its diameter, which is 3 meters. So the radius for the well will be 3 by 2 meters. Its height will be the depth of the well, which is 14 meters. Now for the embankment, since there is width, so I'm first of all going to write down the width of the embankment. This is 4 meters. I would like to use a small r and capital R, but I have already used small r. So I'm going to use R1 and R2 instead. If you want, you can use capital R and small r for the embankment. And for the well, you can use R dash or R1, or in case you want to use something else. So for the embankment, the inner radius will be same as that of the well. So this will be 3 by 2 meters, as you can see. And then the outer radius, I'm taking it as R2. This will be the inner radius plus the width of the embankment. So this will be 3 by 2 plus 4. This is 1.5 meters, and this is 11 by 2, 5.5 meters. Now the volume for the two will be same. The volume of the earth dug out of the well will be equal to the volume of the earth used to make this embankment. And that's what I'm going to write down. Volume of earth dug out of well will be equal to volume of earth spread to make or form the embankment. Once you have the parameters, you only need to be careful how you write down the volume. For the well, it will be simple pi r square h, whereas for the embankment, the height is not given. Let's represent the height with capital H. It's not given to me. So this is what I want to find out, the height of the embankment. This will be pi r2 square minus r1 square multiplied by h. If you are using capital R and small r, this will be the area of the ring multiplied by the height. You can also use this. Use the values, pi gets cancelled. You have 3 by 2 squared multiplied with 14 equals to 5.5 squared minus 1.5 squared multiplied with h. Simplify and obtain your answer. So h will be 9 by 4 multiplied by 14 into 1 over, this will be 5.5 plus 1.5, 7 multiplied by 4. Is this the answer?
Yes, ma'am. 1.12.
Ma'am, 1.125.
1.15.
Okay.
5.
I hope no one's writing. Let's take a look at the last two questions. Again, last two questions are important. The two questions that we did, the ones with the well, those are important as such. And then these two, the last two questions are important. Water in a canal 6 meters wide and 1.5 meters deep is flowing with the speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeters of standing water is needed? Now, you had a question similar to this one last year where the water was flowing in a river and you had to find out how much water will flow into the ocean or fall into the ocean in the given time period. So here the water is not flowing into an ocean, it's flowing into an area to be irrigated. The area of the field is to be calculated where the height of the water is 8 centimeters. So the first thing you notice is there is a difference in the units. So we have to be careful about that. The dimensions for the canal are given in meters, whereas the speed is given in kilometers per hour. So there is a change in unit. And then afterwards, the area of the field for which, the field for which we have to find out the area, the height of the water is given as 8 centimeters. So there are three different units. You can solve the complete question in centimeters, or you can choose somewhere in between, like in meters. Then time given is 30 minutes. So वो भी change हो रहा है hours to minutes. Be careful about that. First thing we will do is, with the help of the dimensions of the canal and the speed of the water, we will find out how much volume of water is flowing through the canal in 1 unit time. So 1 unit of time here is 1 hour. With the help of these width, depth, and the distance covered per unit time, we will find out the volume of water that flows in 1 hour through the canal. And since we have been given the depth and the width, we will be representing the canal in the form of a cuboidal pipe. So I'm just going to draw a figure roughly. This is question number 8. So let's represent the canal as a cuboidal pipe. So I'm not showing the whole portion here. And this is given of depth 1.5 meters. The width is given as 6 meters. And the speed at which the water is flowing through this canal is given as 10 kilometers per hour. Yeah, of course, it will help you understand if you draw it. Otherwise, if you don't draw it, that's completely fine. बिना draw किए भी आप कर सकते हो. It just gives you an idea what's going on here. So the speed which is given to you is 10 kilometers per hour. I would like to divide this canal into sections of 10 kilometers length. So let us say the distance till here. This distance is 10 kilometers. And then further, similarly, I could divide the canal like further. This distance is 10 kilometers. So what happens in every hour, the water from these sections transfers to the next part. So since the water is flowing straight path, एक hour के बाद whatever volume of water is in the first section, इस section में जितना पानी है, 1 घंटे के बाद वो next section में चला जाएगा. Water is flowing continuously, so this keeps on going. पीछे से पानी आता जा रहा है और आगे move करता जा रहा है. तो 1 घंटे में पानी कितना travel करता है? Like what volume of water travels in 1 hour will be given by the volume of water in this section, this cuboidal part of the canal. This is the volume which flows in 1 hour. So we can find out the volume of water flowing in 1 hour. By calculating the volume of this cuboidal section, that will be given by L into B into H. Now, kindly note down the dimensions carefully for this cuboidal section. The length will be taken as 10 kilometers. This is taken from the speed, the distance. Then the breadth is 6 meters and the height of this section is 1.5 meters. I'm going to convert these. This will be 10,000 meters and then use accordingly. 10,000 multiplied by 6 multiplied by 1.5. This will be cubic meters because the units are now meters. Now from here, since this is for 60 minutes, I'm going to find out the volume of water which flows in 30 minutes because that's the time for which the field is being irrigated. So volume of water flowing in 30 minutes. You can simply take the volume and divide it by 2, or you can apply unitary method. Unitary method would mean volume for 60 minutes divided by 60 into 30. 60 मिनट्स का दिया है, हमें 30 मिनट्स का निकालना है, तो मैं डायरेक्टली इसको हाफ कर रही हूँ. I hope that makes sense. This is again in cubic meters. Now this water which is flowing falls into a field. And the height of the water in this field is 8 centimeters. You have to find out the area of the field. पानी गिर रहा है फील्ड में और कितना स्टैंडिंग वाटर रिक्वायर्ड है 8 centimeters is the height of the water in the field. So there is one thing you can do. Either you can write down that the volume of water in the field. Just watch and let me know if this makes sense to you. If you want to write this way, then you will note down. Otherwise, I will just tell you how to directly find out the area. So volume of water in the field will be given by area of field multiplied by the height of water, height of the standing water. This is the formula by which you can find out how much water is there in the field. Area multiplied by the height of the standing water. So we need to find this. Height is given to us as 8 centimeters and the volume of the water in the field will be equal to the volume of water that flows into the field in 30 minutes, because irrigation जो की जा रही है वो 30 minutes के लिए कर रहे हैं. तो this will actually be equal to volume of water flowing into the field in 30 minutes. So you can use this relation in order to find out the area of the field. You can skip this part and directly write down the area of the field which is being irrigated equals to the volume of the water which is used for irrigation divided by height of the water which is standing in the field. So you can directly use this relation in order to find out the area. So whichever seems convenient to you, you can note it down that way. You could write down the two intermediate steps and then conclude this, or you could directly write this down that the area of the field which is being irrigated will be given by the volume divided by the height of the water. And then the volume we already have in cubic meters right there. This is 10,000 multiplied by 6 multiplied by 1.5 over 3. This is in cubic meters, and the height of the water is 8 centimeters. Now you can convert the units here and then solve. Conversion karni hai. Each of these units will be converted into centimeters. So do this carefully. This gets converted into 2. We have 10,000. And then solve. The answer will be in centimeter square because it's area. Simplify and obtain your answer.
Excuse me, ma'am.
I have noted that. Yeah, my mistake. I'll just change that. This is 3, not 2. 2, not 3. Okay, simplify and obtain your answer. This gets cancelled. The decimal will be cancelled with 0. You can cancel this with 1 to 5 into 0 and then obtain your answer. Just be careful with the number of zeros. This will be 1, 2, 3, 4, 5. And then if you want, you can convert it into meter square by dividing by 10,000. Done?
Yes, ma'am.
Yes, ma'am.
Last question. A farmer connects a pipe of internal diameter 20 centimeters from a canal into a cylindrical tank in the field. The tank in the field is 10 meters in diameter and 2 meters deep. The water is flowing through the pipe at the rate of 3 kilometers per hour. In how much time will the tank be filled? You can again draw a rough figure for this in order to understand what's going on. Else you can just directly do the question. So I will be showing a rough figure. This is question number 9. There is a pipe which is cylindrical in shape and
Excuse me, ma'am.
yes,
Ma'am, question 8 में एक और zero है पीछे.
1, 2, 3, 4, 5, 6. Let me check. 1, 2, 3, 4, 5, 6. Okay.
Yes, ma'am.
I missed the last one. All right. 562500 meter square.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So there is a cylindrical pipe through which the water is flowing. It is connected to a canal and the water is falling into a cylindrical tank. So this is what's happening. Water from the pipe is falling into a tank. You have been given the dimensions for each of these. For the pipe, the internal diameter is 20 centimeters. The speed of the water is 3 kilometers per hour. From the speed, we will be using this distance as the length or the height of the pipe or the section through which the water flows in 1 hour. And then the tank in the field is 10 meters in diameter and its depth is 2 meters. So let's use the representations for the tank in capitals. The diameter is 10 meters. From here, the radius will be 5 meters. And then the height is 2 meters. And then for the pipe, the diameter is 20 centimeters. The radius will be 10 centimeters. And then the length of the pipe, with the help of which we can find out the volume of water, can be taken as the distance from the speed itself. So height will be 3 kilometers. And then volume of water will be given by the sectional formula pi r square h. And then you can find out the volume of cylindrical tank to be filled. This will be pi capital R square h. Time taken. How would you find out the time taken?
Ma'am, required time equal to volume of cylindrical tank over area of face of pipe into length of water.
Okay. So sectional formula bol rahe ho. Section into the speed will tell you the volume of the water flowing. So volume of the water flowing in 1 unit time. This will be pi r square h over pi small r square h. Simplify and obtain your answer. Be careful with the units here. The pipe has units in kilometers and centimeters mixed. I'm going to just write that down. This will be 10 into 10 centimeters square and then multiplied by 3 kilometers. And for this one, this will be 5 into 5 into 2 meter cubed. I'm converting all the units into centimeters. So now it's centimeter cube and centimeter cube. The time will be in hours. Simplify. So you're left with 5 by 3 hours.
Ma'am, 100 minutes.
You could leave the answer in 5 by 3 hours. You can convert it further into minutes by calculating this way. Even if you leave your answer in 5 by 3 hours, that's fine. The answer at the back of your book is given in minutes, so you can convert to obtain the answer. That's fine. Anyone with